we're going to take it a step further and say, what happens when we have a chemical reaction going on and we want to look at this chemical reaction? We can use molarity to obtain some useful information if we are also using mole ratio and things like that. So I have this diagram, and it says for the balanced equation in green up here, the lowercase letters are your coefficients, capital letters would be your reactants and products. Okay, so A and B making C and D. And for any balanced chemical reaction that involves where maybe your reactants are not solids, maybe they're two solutions. Okay, so maybe we have a mixture. This is most applicable for a situation where we have a mixture of solutions. Okay, and the things that are reacting, A and B, are in solution form. Okay, and if we know the molarity of these solutions, which we should if we made them and are mixing them, then we can calculate how much product we would get or what the concentration of our product would be. Okay, you've actually seen a diagram like this before back in chapter 6, except for we did it with molar mass. So in chapter 6, you had a diagram. I'm going to write it out real quick. It was like if you have the mass of A, you can convert to moles of A, then you can convert to moles of B, and then you can convert to the mass of substance B. And we had a whole lab, our mole conversions lab, where we would practice plugging in the molar mass for a given chemical reaction. That would be step 1. I remember I called it the 3-part problem. Step 2 would be plugging in the mole ratio. And then step 3 would be plugging in the molar mass again of your other substance. Okay, this is the same thing. This diagram is the same thing, except for instead of molar mass, we're using molarity. Okay, look, the second step is actually identical to the second step in the other diagram, plugging in the mole ratio. And then instead of a molar mass, again, we're just using a molarity. Okay. So I'm going to erase this diagram on the right because I don't want anybody to be confused what we're talking about and what we're using this time around. I just want to remind you, you've seen this concept before, so hopefully it's not too complicated. We're really not doing anything new except for using molarity instead of molar masses. Okay, so if we have the volume of a given solution, substance A, we can use the molarity to convert to moles of substance A. Then we use the coefficients in the balanced equation to find the mole ratio, and we use that to convert from moles of A to moles of B. And then we can use the molarity of substance B to figure out what volume of solution B maybe we want to react with a particular volume of solution A. All right. I have 2 practice problems on this. The first one, this one right here, is actually not a perfect fit for this model because it has you, or this diagram, it has you start with milligrams of this magnesium hydroxide tablet, which is not a volume. And I want to exactly follow this diagram since I just introduced it. So I'll come back and work this problem, or I think it's a great problem to try to work. I think you have the tools to work it now. But I want to work this second problem. So find this slide, and it says molarity and stoichiometry. Stoichiometry is just a fancy word for using a chemical reaction to calculate or convert and find useful information, essentially is what that is. All right, hopefully you found the slide. So calcium carbonate, let's read the problem, reacts with hydrogen chloride, which is hydrochloric acid, to make calcium chloride, water, and carbon dioxide. How many milliliters, so this is what we're trying to find. How many milliliters of a 0.22 m, and I will read that as 0.22 molar, okay, solution of calcium carbonate are needed to react completely with 25 milliliters of a 0.5 molar solution of hydrochloric acid. All right, so we have a solution of calcium carbonate, we have a solution of hydrochloric acid, they're going to react. We know the volume of our hydrochloric acid solution, but we want to say how many milliliters of our other solution do we need to get the right reaction. So the first thing, if I give you a problem like this, step 1 is write a balanced reaction. Okay, so calcium carbonate. Calcium and then carbonate is CO3. Calcium is a +2 cation, carbonate is a -2 anion, so we just need one H, CaCO3. Then it says reacts with hydrogen chloride, which is just HCl, hydrochloric acid. To make, so now here are my products. I have 3 products I need to write. So I'm going to draw my arrow. Calcium chloride. Calcium is a +2. Anybody remember what chloride is? As though you guys can tell me. -1. So I'm going to need 1 cation, and I'm going to need 2 chlorides. So it should be CaCl2 plus water. You guys know water, H2O, plus carbon dioxide, CO2. It does not tell me to include the states of matter here, so that part is not important right now. But these are going to react, and we need to balance it, don't we? So I have 1 calcium on both sides. I'm going to need 2 H and 2 Cl on the reactant side. Is it now balanced? 1 carbon, 3 oxygens, and collectively, I think we're good. I think that's it. So here's the balanced reaction. How many milliliters of a 0.22 molar solution of calcium carbonate are needed to react completely with 25 milliliters of a 0.5 molar solution of hydrochloric acid? Okay, so rereading that question part, we have to go back to our diagram. We have to start with a volume, okay? And it says right here that the volume, start with whatever volume you're given. Now, it says start with the volume of solution A, okay? The only reason it's saying A here is because it's trying to get you to think about this generic reaction up here. We don't have any A's or B's or C's or D's in our equation. We have actual molecular formulas. So I want you to find the one volume that you're given and write that down. That's what you're going to start with. So if you're looking through the problem, the only place I see a volume is right here, 25 milliliters. So we're going to start with that, 25 milliliters of what? This is hydrochloric acid that we're talking about. Okay, so I'm going to write that in, HCl. I encourage you to write your substance in, label things with what substance you're talking about. And now, what is the first step we do? So we want to use the molarity to convert to moles, okay? Now remember, molarity is moles per liter, okay? The volume unit there is liter. We are not starting with liters, are we? We are starting with milliliters. So there's actually a pre-step here where we need to convert milliliters to liters, and then we can use that to cancel liters and convert to moles. Okay, so we're starting with milliliters, so this is the first step we need to do, is convert to liters, and then we can plug in our molarity. So I'm going to come back down here and quickly convert this to liters. So there's 1,000 or 10 to the power 3 milliliters in 1 liter, and now milliliters cancel, and if we calculated this, we would have liters, which we don't have to. We can just keep going. So now, this is my step 1 in my 3-part problem. Okay? Technically, the first step was converting milliliters to liters, but if we're actually following the diagram that I keep scrolling back up to, this is step 1. We're going to plug in the molarity, okay? So what is the molarity of HCl? Go find that in your problem. It says 25 milliliters of 0.5 molar solution HCl. So it's 0.5 molar. And remember, this 0.5 molar, well, is moles per liter. It's 0.5 moles per every 1 liter. That's what the capital M stands for. So I'm going to separate out those units or write them all in. And I want to cancel liters, so for every 1 liter there is 0.5 moles HCl. Okay? So liters will cancel. And now I just have moles of HCl. So this was step 1, plugging in the molarity of HCl. So now we're going to go to step 2. Step 2 in these diagrams is always plugging in the mole ratio. And what are we trying to convert between? The question, which starts right here, how many milliliters of a 0.22 molar solution calcium carbonate? So So we're trying to find volume of calcium carbonate. We're starting with volume of HCl. So the two things I'm looking at are right here. I want to get the mole ratio between calcium carbonate and HCl. And if you're looking at the coefficients, that is a 2-to-1 ratio, right? So I have, if you notice right here, I have moles of HCl on top. So I want to cancel moles of HCl. So I want to put the moles of HCl part on bottom in my mole ratio. And I want to put moles of calcium carbonate on top so that we cancel the right thing. And that is a 2-to-1 ratio. So I'm going to plug in my mole ratio there. So moles of HCl cancel. That was step 2. Step 3, if we go back to the diagram, what was step 3? So this is step 1. This is step 2. This is step 3. Okay, now we did have this pre-step, which I numbered 1. But on the actual diagram, 3-part problem, we plugged in molarity, mole ratio. Step 3 is right here. Use molarity as a conversion. Molarity of what? Molarity of your next substance. They're calling it substance B in this diagram because of our equation at the top. But what would be the next substance? What are we trying to find? It would be, we're going from HCl to calcium carbonate. That's what we want to know, how many milliliters of calcium carbonate. So I'm going to plug in the molarity of CaCO3. Do we have that? Can you find that number in the problem? It's the one number we haven't used yet, which is this right here. 0.22 molar, which is 0.22 moles per liter. Remember, this is 0.22 moles per 1 liter. That's what capital M stands for. So this time I want to cancel moles and I want to convert to volume because I'm trying to find out how many milliliters. So for every 0.22 moles, that's how many moles of calcium carbonate are in 1 liter for this solution. And now we see that moles of calcium carbonate cancel. And now we just have liters. So if we stopped here, we would know how many liters of this 0.22 molar solution we would need. The question says how many milliliters. So we got to go one more step. This is not actually on the diagram. But if it asks you for milliliters, you always have to go back at the end and convert back to milliliters. It seems redundant because here we converted from milliliters to liters for HCl. We're not talking about HCl anymore, okay? So we have to now take our liters of the calcium carbonate solution and convert back to milliliters if the question says how many milliliters. So for every 1 liter, there's 1,000 or 10 to the power of 3 milliliters. And once we get our answer now, it'll have the proper units, milliliters. Okay, this was a 1, 2, 3, 4, like 5 steps total. So we're going to do 25 divided by 1,000, or 10 to the power of 3, times 0.5 divided by 2 divided by 0.22, or you can always say times 1 over 2, or times 1 over 0.22, and then times 1,000. And when I did that, I got 28.41 milliliters. So I'm going to have 25 milliliters of my hydrochloric acid solution, and I need 28.41 milliliters of calcium carbonate to react with that at these particular concentrations. All right. This is where I wish I could say any questions, but please write your questions down. If you do have questions on this, like why did she divide by 1,000 or multiply by 1,000 here? Or how did she know what to plug in here? Please write those questions down, and I would love to answer those if you email me or plan to come meet with me on office hours this week. All right, so I told you we're covering like 6 different topics. That gets us to our next topic, I think our third topic here, dilutions. Okay, with solutions, you sometimes have to dilute things or make things more concentrated, and there are ways to do that. Particularly talking about diluting stuff, I'm going to just read this first statement on the slide. It says, we're often given a solution that is more concentrated than we need. This is usually called a stock solution. So we must add more solvent to dilute the solution to the concentration that we need. And the one we're going to need, the one we're working with, is called our working solution. So when you're doing something like this, I know for our university, here in the chemistry department, when you guys show up for lab, everything's already been measured out in the right concentrations in these nice little clear dropper bottles that you often see on the benchtop when you show up to lab. But there are people who work up in what we call our stock room who take our stock solutions. We order things in bulk, since we run a lot of labs in this department. We order things in bulk, and then we have students that are paid by our department to make the right concentration for the labs that students work in and need, and the concentrations in y'all's lab procedure. So the bulk solutions we order are called our stock solutions, and these kinds of things happen all the time when we're making solutions for our labs. So how do we know how much solvent to add to get the right concentration that we need for our working solution? We have an equation for this. It's probably going to remind you of a gas law. Anybody just remind you of P1V1 equals P2V2? Boyle's law. It looks very similar, right? Except for it's M1V1 equals M2V2, where M is the molar concentration in units of molarity, V being the volume. And it doesn't matter if the volume is in milliliters or in liters, as long as your V1 and your V2 match. Okay, so V1 and V2 need to match units. Okay. If you have one that's milliliters and one that's liters, you will get the wrong answer. So anyways, you know how to use Boyle's law, this one right here. And we're going to use the dilution law here. It doesn't have a particular name, the same way. Okay, so we're going to work a problem with this where we're going to be given 3 of these 4 variables, and we'll be looking for the 4th. All right, so let's work these 2 problems, and this dilution is rather a pretty quick topic. So it says I have 75 milliliters of 3.5 molar glucose. I dilute it to 450 milliliters. What is the new concentration? So go through and label. This is the first volume given, so that's V1. This is the first concentration given. I almost wrote C. So this is M1. I'm going to dilute it to my new volume, which is V2. And so what is the new concentration? I'm looking for M2. Now, notice units of volume are both milliliters, so we're good here. We don't have to convert anything. We can just plug it all in and solve for M2. So 75 milliliters times the 3.5 molar, and you do not have to write out moles per liter. You can just plug in M. Is going to be equal to M2, because that's what I'm looking for, so I don't know what that is yet. So I'm just going to write M2 times 450 milliliters. So to solve for M2, I need to move the 450 over. So I'm going to divide both sides by 450. It cancels over here. All of it cancels. And now we just do the math. 75 times 3.5 divided by 450. And you should get 0.58, repeating 3. And the unit there is molarity. Okay, so that is M2. That would be the concentration, the new concentration. All right, one more dilution problem. It says I can buy 1 molar NaOH. I need, so if what you can buy, this is probably your stock concentration. So this is going to be M1. I need 750 milliliters of my new concentration, this is M2, of NaOH. How do I prepare this? Okay, this is the first volume listed in the problem, but it's tricky here because this volume is for M2. I need 750 milliliters of this new concentration. So this is actually V2. That volume goes with that concentration. So when it's saying how to prepare this, essentially what I want you to do is figure out what volume. I would probably word this differently on an exam. I'd probably say, what volume of your stock concentration do you need? and then you dilute it to 750 milliliters with like water or something. So we're looking for V1 is what I'm trying to help you understand here. Maybe you already understood that. All right, so now if we're looking for V1, we know M1, which is 1 molar, times V1 is going to be equal to 0.32 molar times 750 milliliters. Okay. We don't have to convert milliliters to liters here. It's fine to work this with milliliters. We just have to understand that units on our answer are going to also be in milliliters, since that's the starting unit for volume. All right, so to solve for V1, I'm going to divide both sides by 1. Cancels. So we'll just do 0.32 times 750. Obviously divided by 1. It's not going to change the number. So that is going to be our volume of this 1 molar NaOH. We're going to need 240 milliliters of it. And if I were to ask you, remember that slide where I showed you the flask with the yellow powder and we talked through the steps of how to prepare a solution? You could then talk me through, okay, well, actually that's probably not a good example because that was dissolving a solid in a liquid. Okay, forget what I just said. You just tell me, I take 240 milliliters of my stock solution and I dilute it to 750 milliliters with water or something like that. Okay, so that was V1. All right, that's the next big topic in Chapter 9, dilution. So that was kind of quick. This equation's not very complicated. We've seen something like this before. When we worked Boyle's law. And so I'll work more dilution problems before the exam. There's also lots of good textbook problems for you guys to practice with dilution stuff.